So I want to talk to you a little bit about the OEE today and about what artificial intelligence can help to improve the OEE machine productivity. And I want to show you that this is all very easy and all very inexpensive. So let's look at it. The OEE is the overall equipment effectiveness, and that's the true machine availability. And it comprises of availability losses, performance losses, and quality losses. That means that the OEE itself is a KPI that shows how good your machines are running. And if you know that the machine has some certain problems, it also shows you where the problem is, which means that the availability shows you how much of the planned time the machine is running and has standstills, like classical breakdowns, changeovers, missing personnel or something. That is when the machine is really stopping. There's a second loss, which is the performance loss, and it shows you when the machine is not running at the right speed, or you have micro stoppages, something like a minute or 2 minutes of stop where there's no real breakdown, but somebody has to go to the machine and turn a bottle and do those things. And the last one is the quality factor. If the quality is not right, of course, the machine is not producing right output. So the quality is also deducted from that figure, which means that you have three factors. It's the availability factor, the performance factor, and the quality factor, and they all three get together and produce that OEE. Yeah? That concept is working in all manufacturing. It's very common in machine-based manufacturing and in all machines there. But it could also be used in labor productivity, where it's a bit uncommon. Yeah? And most of the time, you can easily calculate your OEE and see how the machines are running. So what is the problem? I mean, the OEE is not very new. So what is the real problem? What we experience is lots of companies do not have the right data. They miss the data in terms of they know their output, they know how much the shift time is, but sometimes they even don't know how long the stoppages are, and they don't know when they occur. And if we come to performance losses, it's even harder to assess. We find manipulated problems, we find employees that try to make the machine look better and all those things. So we have missing data that really hurt us. Due to this missing data, we have a missing understanding. If we don't really know why the machine was stopping, so we don't know the real reason, we cannot do something against it. And this is why it's really hard to optimize my machines. And therefore, we tend to have like a low overall equipment effectiveness. The average, I've taken a study here from McKinsey, the average was 62% in the food area and 66% in personal care and 65% in home care, which is rather high. But we have long chains of machines there with rather, it's not low tech, but it's not super high tech. If you go to the metal sheet machining area or small series production, we find OEEs that are below 40% in average. And you can see that the losses there occur for or account for nearly 60% of all the time. So if you calculate the OEE in your company, you should ask yourself, how large is my OEE? What is the trend? What is the fluctuation? And what are the reasons for this OEE? Taking all these measures and doing them by hand with pen and paper, with like lots of lean management senseis tell you, is okay for the first machine and is also okay for the second machine, but it's not for the whole plant. It doesn't work after a certain amount of machines, and it also creates a lot of bureaucracy and administration. And this is where OEE AI comes into place. What we do is help you to collect the data, transform the data, calculate the data, and visualize the data, which is the whole chain. Yeah. Therefore, we have a very small nano MES, which is a manufacturing execution system, which you can easily plug into your machine. It's a plug and play technology. It only takes 20 minutes to connect to the machine. We bring our own hardware, which is fully industrialized or industrial for industrial circumstances. It works underwater. It doesn't have, it only has a small LED. It doesn't have a switch or something. It's just a capsule box. And you do not have any further IT requirements there. We bring the advanced analytics part, which is calculating all the measures like the mean time between failures, the OEE, show you the reasons, and use statistics and AI algorithms to give you some hints on about what to do. We also visualize trends and improvement proposals. And we integrate the worker, this is the social manufacturing, because there's always some knowledge left at the workers which you cannot grab from the machines. And this worker is most of the time very important to assess because they really know why the machine was stopping. And we use gamifications and incentives to get them more into the system. So that is the solution. And that solution is true plug and play, true international, and you don't have to worry about. Only thing you need is some kind of browser to assess the data. This is why it can be used in all production environments. It can be used in bottle filling, metal sheet machining, drilling, like food production or some constant production or some part production, everywhere like consumer products. How's the technology working? If you look at the complete chain, we have the machine on the left side. Obviously, we don't bring that machine, where we get the data from. Then we have our sensor that you can see here that gets the data from the machine, and it's minimally invasive. So you don't have to put it into the machine, but it's a small sensor that collects output, and using this output to generate a vector, a speed vector, and transferring that speed vector to our European data center. You can also, if your machines are pretty new and use MQTT or OPC UA, you can also use that signal and you don't need a sensor at all. That sensor is sending via GSM 5G. That sensor is also using wireless LAN, Wi-Fi, or Ethernet. So you only need a somehow connection of mobile phone or Wi-Fi. We use the iPads to gather some additional information, or the tablets. We actually use tablets. And it works on every tablet. It also works on your watch. It also works on your mobile phone, where you can use where the employees or the operators can punch in the problems and call for help and all those things. On the other side, we have the data usage, where you only need the browser to access the data, which I will show you later on, the reports. You can also have Andon boards, like on a screen on the line. You can use it on the watch to show or call the maintenance guys, or on any kind of shop floor management boards, digitalized. That's the technology, and we have the full complete chain from the machine to the user, and we have the whole covered everything, which means that you don't need an IT project. You don't need a big investment. Everything is software as a service. Actually, you don't need to worry at all. Just plug it in and it starts working after 20 minutes. What can you get there? Of course, you get the overall equipment effectiveness. You can see the black line showing the OEE of the last week here, and you can see the different grades, the availability factor, the performance factor, and the quality factor, which are all assessed so you know what the problem is. If you look here, you can see that on the 7th of December, the availability was lower than on the other days. On the 4th of December, it was also low, which was dragging down the OEE during that time under a value of below 60%. You also get the visualization of the plant production, which is the output level, which we can see on the bottom. I can increase it a little bit. So if you want to see the actual output, you see the blue line showing the output of the machine. You can see the red line showing the desired output per line, and you can see that on the left side before the changeover. Sorry for the German there. Before the changeover, it was running below the right speed, and afterwards it looks like the machine is really a little bit above the desired speed. That is the actual reason. I think on the left side they used the wrong product. You can also see in reddish the stoppages where there's a stop for changeover. The 905 Rüsten means changeover, which is your individual plan or individual loss reason catalog to easily show and give you an oversight about the problems. And you can see that the OEE here is fluctuating, or you can see that the output is fluctuating. And of course, you can see where the stoppages are and drill down a little bit more. If you want some more detailed reports, you can have weekly reports, like we show the losses and the microstops or the output per day in an aggregated way. And you could also see the different microstoppages and all that. So you have all the possibilities to put your own reports to show and see what to do. So now you know that there is a standstill. Well, you want to know why. You want to see what is our problems in terms of optimization, because in the end, you don't want to see how it's running. In the end, you want to increase your OEE. And this is a question how to do that. So the first thing is knowing why it stopped. That data is easily taken from the iPads, where you have your loss catalog on the back, and the worker punches in the reason as soon as there is a standstill. And you can see here that there is like cleaning of the system is the reason, the biggest reason. Then we have missing parts, manual work, and calibration and all that stuff. This is most of the companies have already a catalog for the availability losses, and that's usually the company's own catalog that we have there. We can see that there's like, as we most of the time find that the organizational losses are like 50% or more. Technical losses due to a technical breakdown or something is usually very low. Everybody is afraid about technical losses, but the real problems is organizational losses. And that is why looking at those OEEs is so important. I'll bring you a small war story later on about the organizational losses, which I think is very helpful. What you can do is do a loss documentation by this, which means that you don't need to fill in any sheet and paper what your losses were, but you get like a direct oversight from what time to which time you had which reason for a loss. And you can all use that for documentation. And most of the time, companies use that for changing all the payment of the employees and all that stuff. Let's talk a little bit about performance losses. That is all availability losses. Yeah, if we talk about this line or these points, we always talk about availability losses, meaning the machine is standing. But the real problem, by the way, is not the availability. The real problem that we find is that the performance is too low. Yeah, because availability is very transparent. If the machine has a standstill, everybody looks at the machine and say, oh, why is that machine standing? And then you have to say, sorry, the changeover took longer and so on. But the performance loss is usually at the same height. When I go back a little bit to the OEE, you can see that the performance grade, or performance factor here, is by far lower than the availability factor. And the reason for this is that it's much less transparent. If the machine is running, like on the left side, with a small gap to the desired time, there is a loss reason. That is a loss. But the loss at that point, is a performance loss. I get the question how the losses are captured. The losses are captured via the iPad. If you look at this chain, the sensor itself has the availability, or the data center is in real time calculating if there is a loss. And it tells you if there is a performance loss, or is there an availability loss, or if it's a microstop. As soon as it discovers a loss on the iPad, it's popping up and showing the loss catalog. And the loss catalog is different. If it's a quality loss, it's green, it asks for the quality reason. If there's a performance loss, it's red, it asks for the performance loss reason. And if it's a standstill, it asks for the availability loss. And then you easily get those graphs to show it. Yeah. So talking about performance losses, what is the problem? The problem here is that most of the companies underestimate their performance losses. And what we see is that there's two factors. One is the lower speed, like running the machine with lower speed, because the operators think that the machine runs better if they run it slower. Most of the time, this is not the case. The better means that if you run it faster, you have more microstops. Microstops are usually are a problem with adjustment of the machines. If the adjustments are not precise enough, you increase the micro stoppages, which is the small stops which are between a minute and 2 minutes. Like very small stops, which lead to, in the end, a performance loss that is quite large. And in average, we find that the performance losses due to the microstops can be quite severe and can be so large that it is less than like 50%. And so it depends, of course, on the type of machines, but we can have per shift, we have between 100 and 150 per shift if it's a bad machine. And most of our customers are between 10 and 30 microstoppers just per shift. So you see that the microstops and the performance losses usually occur for more than half of the losses. And this is really hard to assess and hard to gain. And therefore, you need the desired speed of the product. And of course, you need somebody entering why it's running slower. Here we find that, for example, there's manual work and calibration. You find that cleaning the system is necessary. Sometimes you have bottles falling apart and those things. So that is the performance loss reasons. So what else can we do with it? We do some shift meetings, for example. In the morning, talking together with the shift meeting and getting a report for the last shifts and say what happened. Just a small overview about the different shifts, about the total time, and you can discuss it. You can find some additional KPIs there and some small overview, like using it for regular shift meetings. It's integrating in your meeting cascade. You also have the possibility to have an add-on board, like showing the actual performance of the shift. When you see that shift, I had to be fast this morning because the shift ended at 6 o'clock, so I wanted to have the full shift here. You can see that the shift started at 10 o'clock in the evening, 2200, and goes up to 6 o'clock. And you can see that the OEE of that machine was really running well, was 92.4%, because we didn't have a breakdown in that shift. I was actually checking if it's running right. That's not simulation, that's already data. And they produced in units of 18,000. And this add-on board is meant to be at the line. And what we usually do is we're usually using cheap TV screens, just a screen, and plug in our Andon TV box, which is a small box that has provides internet connection and a small operating system. So you can use an easy screen, a cheap screen, and just plug the box in. If you have a screen that has already a browser, you could also use that browser of the screen, like the new Samsung TVs, they all come with a browser. You can use that browser to open the Andon board, and then the Andon board is right at the line, and all the operators of the line can see what their shift output is. Or what in case there's a breakdown or it's a performance loss, you get a green, red, or blue button indicating the problem, so you know that there is a problem at the moment. Of course, you can have these andons also on big screens and aggregated them together to have them in the shift office. So all the shift leaders can have a look and see which lines are running and which are not. So what else we talk? What do we want to talk about? That's more like descriptive. And what else do we want to talk about? We want to talk about a little bit what we can do with it. Oh, sorry for the German there. And there's really nice functions that you can do with this data. The first thing is, for example, telling you what is the probability of the next malfunction? What is the probability of the next standstill that is coming? And we found an algorithm that looks at the line and can predict the probability of a standstill in the next 5, 10, or 15 minutes. And it tells you also what kind of type that standstill is. So it knows the probability of a technical breakdown, for example, 1 hour after your changeover or 15 minutes after the changeover. So what you can do is you can show, for example, the loss probability for the next 30 minutes. And then you know that you should better send a technician to that line to know, because there is a high probability that the machine will have a breakdown. Or you can find that there is a lower speed than expected, for example, or higher trend of microstops than expected. Go and have a look there. Like having real-time information telling people what to do. That's what we actually do the AI things for.